Symbolab.com couldn't solve this equation. MathPapa.com couldn't solve it. QuickMath.com couldn't solve it. My trusty TI-89 titanium calculator attempted the problem and I thought it just died, but it eventually solved it, kinda. I mean, it was off by like 0.46, which is actually really bad because the answer wasn't even anything crazy. It was like 4 point something. This is what Wolfram Alpha looks like when it knows what it's doing. It gives you some steps and stuff and does it really fast. After a while of loading, it actually did give a decimal answer, which is better than anything else. But my homemade program solves it in 5/100ths of a second. So why is my algorithm so much better than everybody else? Well, it's because I took a different approach to designing the way the equation could be solved. This is the summer after high school ended for me, and I wanted to make an algorithm that solves any equation without any algebra or symbols or anything. So I sat down with a pencil and paper and looked at what an equation really means, but in a graphical view, instead of just looking at the numbers and symbols and stuff. Instead of it being f of x equal to g of x, think of it as left is equal to the right. And then I would do f minus g is equal to 0. Subtract g out of f, and then when does this equal to 0? That should give me my x value. I just apply that to this graph right here. I took f and subtract g out of it. Graph that. Here's the f minus g at the first point, and then the second point. If we consider this our x naught, and this is the absolute value of f minus g, just so we can look for the minimum value of where it's the closest. If we zoom into this point right here, it would look like this. We look at these distances again as we zoomed in, and then we find the minimum here. We have x2. After 5 iterations, our x5 should be very accurate to the value of x that these two graphs should cross each other at. Alright, now let's write the program to do this for us in 5/100ths of a second. Alright, the main idea of this program is we want to have a function that we can just call with an equation and a variable and just solve it. Let's call our function rsolve. Let's put equation and then variable inside of there. This specific program won't solve multiple answers and it won't solve complex answers. I do have algorithms for those too. We're going to edit this function in the future and we're going to make it solve multiple answers and complex answers, so it can solve any equation in any number of answers. This equation is going to be in string form, and it's going to have an equal sign on it. We went left and right. EQ equals equation dot split equal sign left. String of equation 0, and the right is equation 1. Oops, there we go, fix that. And then the right has a -1 attached to it, multiplying because we subtracted it. Our new expression is just the left plus the right. And now I want to name our x naught position. I'm going to call it spot. Start at 0. For j in range 10. It's going to zoom in 10 times. X is equal to linspace. Now the start of linspace has to be spot minus max x divided by 10 to the jth power. I recommend evaluating this yourself so you can actually see where the start point would be, and then the end point is just the opposite of that. Spot plus max x divided by 10 to the jth power. Comma, we want to have 100 points in between. We need this maximum x value. Let's make it 1,000. That means that this linspace is going to go from 0.0 to 1,000 to the right and 1,000 to the left, with 100 points in between. We actually need this linspace. I put it inside a file right next to mine. I call this file mathmod.py, and I have defined linspace inside here. Instead, if you don't want to do this, you could just copy and paste and not have to worry about that, but I'm not going to do that. I'm going to say from mathmod import all. You have to have this in the same folder, and you could just call from mathmod import all. So that's going to call all these functions in here. Now I can use linspace, and I'm going to make y an empty array for right now. We're going to try something. It's actually try do this except print error. If there's a division by 0 or something or an error inside here, it's going to say error. For k in range, length of x, y dot append, we want the absolute value of evaluation of left minus right, which is just expression. We need this expression to change every single time we go through these x values. Expression equals expression dot replace a variable with an x from the x linspace. K spot of the x array. We're just going to pretend like it exists, and then we're going to create it here. It's going to change every time, and then we're going to replace this x of whatever with this k value right here, and we're going to evaluate it. One of the biggest values in Python is 10 to the 200th. It gets bigger, but I'm just going to pretend like it's 10 to the 200th. For I in range length of y, if the y of this position is less than the minimum, then the minimum is now y of I. This spot from above that we were initially at 0 is now going to be changed to x of I. We can move our origin to that spot now, and we can zoom in. This is how we're zooming in. After we do this 10 times, let's return x of 50 so it can be dead in the center of this 100 sized x array. Let's round it to 5 decimal points. You're never really going to have a homework problem that you're going to need more than 5 decimal points. And let's make up a function. This is the one that the internet can't solve. Let's do sine of x. I actually do have a sine inside here, but it's kind of janky and it's actually a series, so it's not that accurate, and a cosine is even worse. It's a sad sight to see, but let's just bring in the math library. We do actually have to import a library, unfortunately. Equals 10 minus plus 2x. We need our variable, which is x. We're going to be solving for x. So you can actually replace this with u's right here. If you just put u right here, it's going to work the same. Or you can put y, you can put whatever, but we're going to replace it with x. This right here, this fixed string is actually, I'm going to go over this in a different video, but that allows us to put in something like 2x caret sign of x. It'll replace this 2x with a 2 times x, and then it'll replace the carets with the double asterisks. But we're not going to go over this right now. We're just do it for the normal convention right now. Let's just figure out what this does. Oh, I forgot something. That was on the wrong side. This should work. Lickety split. We have our answer. Was that so hard? Symbolab.com. I'm going to come back to you guys later with fixing strings and complex solving and multiple solution solving. Alright, later.